morning. Yesterday you should have completed this packet using the online website. So here are what my constructions look like for 1 and 2. These were very straightforward, pretty much copying the video. Down here for number 2, you could have had lots of answers. What I did is I first copied this line and this line so that these are both B, then extended this line and copied this angle here so that this line is parallel, and then I measured out A and then just connected to make my parallelogram. I'm going to highlight my parallelogram in a different color so you can see where my parallelogram is. That is my parallelogram where these two sides are parallel. There were many options with that. Here, construct very straightforward directly off the sheet, off the video. So here's where I did my first problem. So I wanted through point J parallel to AB. What I did is I extended this line and then I started and I copied an angle. Here I wanted perpendicular through this point. So what I did is I put my point on the point, drew this arc here so that I made a segment of which that point's in the middle, and then I did the perpendicular bisector. To make my square, there are many different ways of doing that. What I did is I started out by drawing this line right here. I started at point, I measured A, remember mark your measurement, and I drew this arc right here that's all equal to A. Then I did the perpendicular bisector of these 2 points, we'll call them ST, and created this line L. This point is then up A on L, so this is right angle, this is over A. So I used my measurement for A and went from here to here, measurement for A from here to here. That point A intersection completes my square. Choice 4 is my answer there, and then my order goes 2, 4, 3, 1. So today what we're going to do is we're going to talk about the distance between a point and a line, or parallel lines. Distance between a point and a line is always the perpendicular distance. I'm going to make this bigger. And therefore, when we're looking at this triangle here, if I want to construct the segment that represents the distance from Q, PR, what I need to construct is the perpendicular line for which Q is in the middle. So in order to do that, the first thing you need to do is you need to extend PR. You can then use your compass to make an arc such that Q is in the middle, and then do the perpendicular bisector of that arc. And that line then would be the perpendicular distance from Q. Again, I'm just sketching there, so we will work from there. Okay, so I am back now. Sorry about that. I had to pause while I was recording. So that's how you do a perpendicular bisector. So to find the distance between a line L and a point A on a coordinate grid, we're going to follow these 4 steps. We're going to write the equation of line L. We're going to write the equation of line perpendicular to line L through the given point A. Solve the system, find the point A intersection, and then find the distance between point A and X. I know that seemed like a lot. The best way to do it is we're going to do examples. So here's our example. The line contains 0, 0, and negative 5, 5. So 0, 0, and negative 5, 5. So the first thing I'm going to do is I'm going to write the equation of that line. So to write the equation of that line, I find that the slope is 5 minus 0 over negative 5 minus 0. So 5 over negative 5 or negative 1. It has a y-intercept of 0. So the equation is y equals negative 1x. Now I want to find the distance between that line and point. Find the distance between that line, which is line S, and point V, which is the point 1, 5. So 1, 5 is over 1, 5. So there's point B. So I want to find the distance between point B and that line. So the first thing I need to know is the perpendicular slope is 1. So this perpendicular to -1. And so I need to find the equation of the line with a slope of 1 through the point 1, 5. So if I use y minus y1 equals m times x minus x1, I have y minus 5 equals 1 times x minus 1, which can be simplified to be y equals x plus 4. And that gives me this line. And now what I want to find is the point where they intersect. So the point where they intersect appears to be -2, 2. To make sure I can solve the system, so I set them equal. So y equals -1x and y equals x plus 4. I'm going to set those equal to each other. So -1x equals x plus 4. So that's -2x equals 4. So x equals -2. To then find y, I choose one of those equations. So I'm going to use -1x. Y equals -1 times -2, which is 2. So the point of intersection is -2, 2. Now the very last thing I need to do is I need to find the distance from -2, 2 to 1, 5. So to do that, I use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. The distance is equal to 5 minus 2 squared plus 1 minus -2 squared. 9. Radical 18 or 3 radical 2. So the distance from that line, S, to point B is 3 radical 2. The next type of problem we can do is the distance between parallel lines. So the process is very similar. However, what we need to do is we need to choose a point that's on one of the lines, and then we're going to do the same process. So the easiest point to choose is the y-intercept. So here are the steps. Write the equation of the two parallel lines. Write the equation of the line perpendicular to one line through the y-intercept of the other. Solve the system, and then find the distance from the point, the y-intercept, to the point of intersection. And again, the best way is through example. So we want to find the distance between these two parallel lines. So I'm going to start by graphing them. So our first line is that, which is y equals -3x minus 5. Our second line is this, and we're going to find the distance between the pink line and the blue line. So this one's y equals -3x plus 6. And this line is y equals -3x minus 5. Now, it really doesn't matter which equation you pick a point on. I'm going to choose the y-intercept on the blue line, which is the point 0, 6. Now I'm going to do the same process we did before, which is I want the perpendicular line to the pink line through the point 0, 6. So the perpendicular slope is 1/3. So the equation of the line with a slope of 1/3 through the point 1, 0, 6 is y equals 1/3 x plus 6. So that gives me this red line. And I'm looking for where they cross, that point of intersection. So to find that point of intersection, I'm going to set them equal to each other. So it's 1/3 x plus 6 is equal to the pink line, which is -3x minus 5. I don't like to deal with the fractions, so I'm going to multiply everything by 3. And that gives me x plus 18 equals -9x minus 15. So that's 10x plus 18 equals negative 15, 10x equals negative 33, x equals negative 3.3. Find y, I use one of the equations. I'm going to use negative 3x minus 5. And substitute negative 3.3 for x, so that's negative 3 times negative 3.3 minus 5. I use my calculator to simplify that. I get y equals 4.9. That means the point of intersection over there is negative 3.3, comma 4.9. If we look at our graph, that makes sense. So now what we need to do is we need to find the distance between that point of intersection, negative 3.3, comma 4.9, and our y-intercept that we chose 0, 6. So again, we're going to use the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Command substitute. So that gives me negative 3.3 minus 0 squared plus 4.9 minus 6 squared. So that is the square root of negative 3.3 squared plus negative 1.1 squared, which is the square root of 10.89 plus 1.21, which is the square root of 12.1, which is approximately 3.47850546. If they would ask me for simplest radical form, remember that that is the square root of 12 and 1/10. We need to get rid of, so if we make that an improper fraction, that's the square root of 121 over 10. So we rationalize that by doing the square root of 121 over the square root of 10, multiplied by radical 10 over radical 10. So that's 11 radical 10 over 10. And if you multiply that, you should get the exact same decimal. So this is in simplest radical form. This is our decimal. So that is finding the distance between two parallel lines and the distance between a point and a parallel line. Your homework tonight is out of your textbook. It is written on the backboard. I will also write it here. It is page 221, numbers 9 through 17 odd, 23, 27, and 38. Mrs. Ryder should be able to help you if you have any questions. Have a good day.